Alright, we got a little repair to do on this lathe, nothing really huge. In that last video that I did with making the centering tool for the tools, for the lathe tools, I was hearing a weird noise out of this every once in a while. Kind of like a clack, like a click, 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 something that wasn't normal. And I thought it was just, misadjusted gear mesh in the gear train, or a chip got jammed in there. But I figured out what it was. Now, when I had bought this lathe, I bought it from one of those Craigslist resellers. Those people that go around and buy up all lathes and machine tools and resell them. He was a decent guy and gave me a really good price on it. But when I went to it, this was basically on the floor of his barn. And it wasn't a part, it was all together, but the countershaft was laying off by itself. Now, he had mentioned to me and showed me how the original guy that he had bought it from had this set up. And this pulley right here, this step pulley on the countershaft, was reversed. Alright? And the motor that's mounted right here wasn't mounted here. This was off of this plate. And what the original owner had, he had this giant L bracket piece that the motor mounted to, and then that mounted to the countershaft, and the whole countershaft was mounted upside down and backwards, floating around the top of the lathe, something here. So in other words, it wasn't it was mounted up above the lathe instead of on the back of a bench. It was a really weird setup. And on the back side here, on the back side of this leg of the mount, was a piece of square metal that was welded there. Not very well, because I was just able to bang it off with a hammer and grind the weld down. I was welded there to accept this turnbuckle, and the turnbuckle was physically shortened. Only one piece of it. It was just really weird. So obviously I put it back to the way it was. Now, I didn't notice the problem that I'm having now when I rebuilt it. It could have been something I glanced over and just didn't realize, and it could have gotten worse over time. But that clanking noise, when I took off the chuck to clean everything up, I was looking at the back of the chuck here, and you can see there's a dark mark on the outside. That was never there, and that is a wear mark. And what that is this pivot pin for the countershaft assembly. There's a cotter pin back here that holds it in place. I actually broke the cotter pin taking it out, but that entire pin, let's see if you can see it better right there. Well, actually, let me get a scale real quick. It's kind of hard to see if it showed up on this little screen, but probably show up better like that. You can see that entire screw there. Get it against the white background. White background there. The entire screw is completely bent. So we have to make a new one. You actually see the area right here. Let me zoom in a little bit. I had to mess with the focus of the camera a little bit, but you can see it right where it raised up, that area where it actually bent. So we got to make another peg and drill a hole for it. Now, I don't have that size cotter pin. I have one that's slightly bigger here, which is 1/8 inch. So we're gonna drill this for this cotter pin here instead of the original one, because the original one broke when I took it out. So we're gonna have to remake this pin, and I'm gonna take some quick measurements of it, make a quick drawing, because this has to go back in the lathe for it to work, obviously. So I'm going to measure the outside diameter of this, the length, the diameter of this, and the length of this head. And I'm also going to measure the bore to see how much of a difference there is between the diameter of this peg and the diameter of this bore. And I'll just make up a quick drawing so that way there I don't have to remember everything, and go from there. In the meantime, I'll get, see what pain in the ass to get in there. It's all warped. In the meantime, what I'll do is just get, since I don't have one of those cotter pins on hand, I'll just get a small screw and just shove it down in there so that that doesn't back out and hit where I don't want it to. And just a quick little aside here, somebody mentioned in one of the comments on the other video of the tool height adjuster, said that the back ways of the lathe, they're not level with the front. And he has the same lathe that I do. And it's extremely possible that his are not. It could be a model difference, it could be a year difference, it could be a number of anything. But this one, let me get you a better angle there. You can see we're dead in line and we're dead level off of that bar. So the height adjusted that I made is perfectly valid and accurate on this lathe. Like I said, it could be just a difference in the age of the lathe itself. Since this is a 1950, they did change them a little bit throughout their life, and sometimes the newer ones have the different kind of looking headstock. They got the big covers and stuff like that. Same thing with the 10Ks are slightly different. And it could be just chalked up to that, but I mean, as you can see by that level, we're pretty much dead level on that saddle there. So let me just run over to the bench real quick, make up a quick sketch of the measurements I need, and we'll select some stock and see if we can just bang out this peg real quick. Okay, so we just got a quick little drawing of what we need. 5/8 on the end there. 120 thousandths is the thickness of that little outside flange. Now that's the most critical dimension of this entire thing, because the actual chuck ends up really close to that. So I want to hold that tolerance there. I want to get that as close as I can. This length of 1/900, not really critical, as I have plenty of room before I hit the back gear. And the diameter of that right now is 3/8, but the actual bore is 384 thousandths. So I might want to make this pin just slightly tighter. This probably was around 3/8 at some point and has just worn to that. So we might shoot for somewhere around 380, 379, just slightly bigger than 3/8, just to make that a little tighter, just so there's no wobble in it, because the handle, the actual tensioner handle, is trapped between the actual headstock casting and this flange here. So we want that tight. We don't want that to wobble around, because like I said, we don't have very much room between the end of this and the actual chuck. Now the only piece of 5/8 stock that I have is actually stainless steel, so that's what we're going to make this out of. I have plenty of 3/4 and stuff, but rather than having to turn down a crap load of the diameter there on a piece of 3/4 inch stock, we're just going to use this 5/8 stainless steel. So I touched up all my tool bits. This had a little, there's a piece. This had like a little turn piece on the end that I was using for something at some point, so I parted that off there, and we're just going to bring it out to pretty much the length that we need. Let me grab my scale. So that parting tool here, that's as close as I can comfortably get. So we'll bump this out to That's about 1/900 right there. So that's pretty good. The turning tool set up. We got a dial indicator set where we need it, and we're ready to turn our length and our diameter. So I'm going to take off about 245 thousandths. Will get me down to 380, just where I need to be. So zero our dials, zero touch. By the way, this would be an ideal time to use collets. It would be real easy to move this in and out wherever you have to. But I don't have any collets. The 3C collets only go up to 1/2 inch. So now this is stainless steel, so let's try something like taking off 50 thousandths total, so it's 25 per side. Give it some speed here. Let's do see how it tolerates this. Purposely did that to break the chip. You get these little stringy guys. Finish isn't too bad, but I don't like those stringy chips, so let me see if I can speed it up. Speed up the actual speed. Keep the feed rate the same. Breaking a little bit now. Now they're breaking, so. I just bumped the feed in to 100,000, double what we were. Okay, not too bad. So let's get our pounding tool back in here. So let's get our let's get this. Let's get this indicator out of the way here. And I'll get our tool post all broken loose. Line it up against our jaw. Looks good there. Tighten her down. So from that point there, and put my dial indicator back on my carriage here. From that point there, we want what, 120 thousandths. So 10, 20, 30. Yeah. From that point right there, $120 thousandths plus the diameter of the cutter here, which is 3/32. Okay, that should be it right there. So I'll slow our speed down. I'm gonna give it an extra 3 thousandths to face the end off there. Actually, we'll give it an extra 5 thousandths here. Away we go. Carriage. No. Butterfingers over here. Okay, so there's the pin. Let's pop loose this chuck and make sure she fits. Okay, I got it to fit. I just had to polish it slightly with emery. It wanted to go in, but it was tight on. It went in fine into the headstock, but it was tight on the handle here. So now we slide nice and into the handle, and we're tightening the board. Just a slight hint of wiggle there, but absolutely nothing in here. Actually, it clicks into place there. So what I have to do right now is put that back in, and we have plenty of clearance on the back of the chuck, so we're not going to hit that. Put that back in, take off this guard here, lathe is unplugged, so that way I'm not in danger of chopping off fingers or anything. And we got a scriber here, and all I'm doing is running down the inside of this casting and putting a scribe line right against where it comes in. So that's where, get this out again. It'll show up on camera right there, but that scribe line is where I want the end of the drill, the drilled hole to be. I want the drill hole a little closer in the middle, and basically I want the end of the hole to come up to that edge, so that this way there the pin is nice and tight in that sandwich between the casting, and I have no point into going in and out. So I just got to drill an 1/8 inch hole right there, so I'm just going to do that in a drill press. I'm not going to film that or anything. I'm just going to use my V-block. I'm going to center punch it, use the V-block, drill an 1/8 inch hole, and we'll come back here. Okay, so we have the hole drilled. Everything's the hole's in there, and we just have to put her together. So get everything back together here. Sorry if my hand's in the way. I'm gonna make sure that that pin is in a place where I can get it. See the pins. If you get a better angle in there. It's kind of hard to get this angle in there, but sorry if this comes out crappy, but you can see that the that hole is right up to the edge. I'll get some handheld video of this. So this pin, that's right into place. Let me just grab a baby screwdriver. Okay, so there's the clearance we have between the back of the chuck and that piece. There's the little bit of gap that we have in there, and there's the pin. I'm just going to bend those up a little bit better. I just got to get a pair of pliers that'll fit around that. I don't have them in the cellar down here. I have them out in my van though. So, whoops, that's pulled up. That's about the amount of movement that we have, and it's not moving beyond that because of the chuck. And when we tighten it, we can go back to the same spot there, and we still have that clearance in the chuck. So just so we got plenty of clearance in that pin, and we're not going to hit it anymore. So that's going to take care of that noise, and that's it for this little repair. So tomorrow, hopefully, I'll be taking a little field trip, not to a place that is really machining related, but pretty sure you guys will find it interesting nonetheless. So we'll see how that goes tomorrow, and maybe we'll have another video up of that.